Hello everyone, good afternoon to all of you. Hello once again. So this live session will be a little bit a different live session, okay? And in this live session we will be talking about I will be answering some of your questions that you already have, and it will take maximum 15 to 20 minutes. Then we will be starting teaching. We will be solving a lot of numerical questions, okay? Yes, same to you, same to you, same to all of you. Okay, so as I was telling you that okay, definitely, yes, Nishant. So as I was telling you, what we will do, we will just talk about some like Q&A session. We will be doing Q&A session first, then we will be doing like a session on numerical answer type questions from like Bohr theory. Okay, and I will be telling you some shortcuts method to do that, or actually this is a continuation video of benzene batch, so that I will be continuing. Fine. Yes, good afternoon to all of you. So whatever your question you can ask me, because a lot of time it's been a lot of time that I haven't joined or come in this live session, and I didn't answer you a lot. Okay, it's been a lot of time, so I'm thinking that yeah, I should come and like solve some of your issue that you are facing maybe whenever you are preparing like that. Okay, that's all. So let's try that. Okay, because I know that some of you are preparing well, but maybe some of you are having some problems, maybe. So that's why I wanted to I wanted to take some questions from you, and we'll be trying some problems, we'll be solving this problem. Okay, because I know that whenever you are preparing, maybe you are not understanding that what you are reading and from where questions you will be facing or not from a particular topic, or which topic you don't need to read, or which topic you need to ignore, which topic you need to focus more. Okay, yes, definitely. Okay, whatever you are, molecular spectroscopy is very important chapter, and it's one question generally comes from every year from that chapter. Okay, that's why I was telling you that each and every topic whichever are present in your JAM syllabus, you would be facing questions. One question you would definitely face, maybe you can face two questions, okay, but one question you would definitely face, because that topic is in your syllabus. Fine, because that topic is in your syllabus. Fine, so you can't ignore that. Even molecular spectroscopy is a very important chapter. Even that is the second most favorite chapter of mine, because after atomic structure, quantum mechanics, quantum chemistry, the second chapter is that which I love the most. Okay, so that's all. Okay, so I love that chapter basically. And from that chapter, what kind of question you would face? You would face like questions on like harmonic oscillator model, anharmonic oscillator model, number of vibrational mode of like motion, number of rotational mode of motion, which molecule is showing like rotational spectroscopy, which molecule shows like vibrational spectroscopy. This kind of question you will be facing from that particular chapter. Okay, so that I will be telling you whenever like we will be in benzene batch. Definitely we will be talking about this chapter, definitely. Fine. And then second question I am getting like JAM 2019 question contains 7 marks molecular spectroscopy. Okay, that's great. Okay, that's great. But maybe you are considering both like physical chemistry and organic chemistry spectroscopy, isn't it? Tell me, isn't it? और मिनहास ही इज आस्किंग लाइक सर फोटोकेमिस्ट्री क्वेश्चंस आते हैं क्या? डेफिनेटली फोटोकेमिस्ट्री से क्वेश्चंस आते हैं, बट सिलेबस में है फोटोकेमिस्ट्री, बट वहाँ से क्वेश्चन आपको डायरेक्टली नहीं मिलेंगे क्योंकि आज तक नहीं आया, तो आप उस टॉपिक को फॉर द टाइम बिंग छोड़ सकते हो, बट मैं रिकमेंड नहीं करूँगा क्योंकि जो बियर-लैम्बर्ट्स लॉ होते हैं ना, उस लॉ से क्वेश्चंस आ जाते हैं. फोटोकेमिस्ट्री के एक ही पार्ट होता है जो बियर-लैम्बर्ट्स लॉ या लैम्बर्ट्स-बियर्स लॉ, उस पार्ट से क्वेश्चंस आ जाते हैं. ठीक है, इसलिए मैं बोल रहा हूँ टॉपिक को छोड़ो मत. तो आपको ये जानना होगा कि उस टॉपिक से किस पार्ट में से क्वेश्चंस आते हैं. ठीक है, सो यू हैव टू नो दैट किस टॉपिक, उस टॉपिक से किस पार्ट से क्वेश्चंस आते हैं. नंबर ऑफ सिग्नल, ओके, दैट्स फिजिकल केमिस्ट्री, नॉट दैट्स द ऑर्गेनिक केमिस्ट्री स्पेक्ट्रोस्कोपी. ओके, इट्स NMR, IR, UV, that's organic chemistry spectroscopy. In case of physical chemistry spectroscopy, as I told you, like let me write over here, like harmonic oscillator model, right? Harmonic oscillator model, anharmonic oscillator model, then like number of vibrational mode of frequency, number of rotational mode of frequency, the molecules which shows rotational mode of motion, the molecule which shows vibrational mode of motion. So you need to know those things from that chapter, because question generally comes from that part. Fine. Yes, but photochemistry is not generally I won't say that it's not important, but I haven't seen any question from photochemistry till now, except Lambert-Beer's law, LB law. Except LB law, I haven't seen any question from photochemistry. Fine. So that's all. That's how generally question comes from that particular part. So as I told you, at 4:45 p.m. I will be starting solving some numericals on that. Okay, some Bohr theory, that those are very important for your JAM examination. Fine, those are very important for JAM examination. Like I will be telling you what is this LBP-BPH. What is this? Actually, this is a revision session like that, because in benzene batch I have already told this thing. What is this LBP-BPH? Even I will be telling you that one. Nothing to worry. I will be telling you that one also. Okay, LBP-BPH. What is that? It's a shortcut method. Okay, it's a shortcut method, and then I will be showing you what is alpha line, what is beta line, what is gamma line, what is delta line, how to understand this alpha line, beta line, gamma line, delta line, how to understand, how to get those. I will be telling you everything. At 4:45 p.m. I will be starting my session. Fine. And not only that, along with all these things, as I was telling you already, in benzene batch, Hindi or English, whatever you say, 100 plus lectures are already been uploaded. Nearly about more 100 lectures will be uploaded within 1 month, within this month, within the month of November, and the syllabus will be completed. Okay, then at least a lot of chapter wise mock tests has been conducted. Then as I told you, daily live classes are going on over there. It's okay. So yeah, I am also considering for JAM 2022 students right now, and their session will be started from, I think, from November, late November, or from 1st December. I will be starting JAM 2022 live session, and the classes will be all live. Okay, all the classes will be live classes, and sometimes if I am not available, then all the classes will be recorded, because I have made all the videos, but I just want to teach my students live so that they can really interact with me. Fine, that's the logic. But sometimes if I am not available, then all the classes are already there, so they can just get those things from the recorded lessons. Okay, so as I told you, already 100 plus lectures are already there, so that's amazing. So whenever I was starting, I started like 3 months ago. I didn't think that 100 students, more than 100 students would join, but yeah, now total number of students is like more than 100. Well, that's quite amazing. So that's why I was thinking, okay, so I should notify other students that yeah, more than 100 students has joined that course, more than 100 plus lectures are present over there, more than like chapter wise mock tests are present in your corresponding benzene batch. So a lot of things are there already. Okay, so what's the time? Okay, we have 10 minutes left. After 10 minutes we will be starting, and whenever we will be starting, I just invite all of my benzene batch English students, because this video will be continuing in English. So I'll be inviting my students, benzene batch students, so they will join, and also you can also definitely join this one because you are already watching. So I'll be solving those numericals, 4-5 numericals. If you can solve, if you understand all these 4-5 numericals, you can definitely like solve any kind of numerical that you would face in JAM examination. So out of these 4 numericals, I will be solving 3 numericals. Okay, and I will be telling you to solve 1 numericals yourself. I will be telling you to solve 1 numericals. Okay, but all other 4 out of these 4 numericals, I will be solving 3. And what kind of questions you will be getting, that I will be telling you over there. Fine. So till then, if you have any specific question, you can ask me. You have any specific question, you can ask me just right there. Okay, there is no issue with that. Any specific question, because whenever you are preparing, maybe you are facing, but you are thinking, okay, should I ask or not? Yeah, you can ask me anything. You can ask, because that's why I gave you this 10 minutes, and that's all. Okay, because a lot of time has been like maybe like 2 months or 3 months ago, I just took this kind of Q&A session. So for that I was thinking, okay, I should give you 20 minutes or 30 minutes 15 minutes time to ask your like questions. Okay, so you can ask me whatever questions you do have, you can just ask me. Fine, because you just got like silent. Why are you silent? I'm not getting it, because yeah, I just generally teach on YouTube. Okay, but that's why maybe you are silent, because I haven't done those kinds of live session that I was doing whenever I was in IIT. But yeah, now actually I am very busy in taking live classes daily. Generally I take 2, 3, 4, 5 live classes daily. Maximum it becomes 3 live classes. Sometimes it becomes like 4 live classes in a day. Okay, so that's the problem, that's the thing. Fine. So yes, up to, at 4:30, 4:45 I'll be starting taking classes again on like atomic and molecular structure. Okay, that's the thing. So till now, whatever questions you do have, you can just ask me. Otherwise, I'll be just wait for 5 more minutes, 9 more minutes. I'll be starting then. Okay, because I just have given a particular time limit for you, and that's all. So what happened? What happened, guys? You are not you are not responding. I can see that 8 students, 7 students are there already. Okay, or are you like doing something else? No response. Okay, then wait for 5, 9, 8 more minutes, then I'll be starting. But before I start, I just want to, okay, is there any test series start from JAM 2021? Yes, I have started taking test series already. That is present in my application. Okay, so yes, chapter wise test series and like part wise test series, then like yes, chapter wise and part wise, and finally full mock tests are also there. Okay, maybe like 15-16 tests already has been uploaded. So yes, those are already there, and I'll be uploading each and every test every Wednesday. Okay, so I'm uploading daily. So before JAM 2021, because you have like 3.5 months you are already left. Okay, so you can do a lot of things in this 3.5 months. You can like start from the beginning and you can finish the whole syllabus if you want. So that you can do in this 4 months. Okay, 3.5 months. So that's okay. And as you can see, so I am getting a lot of assignment submission. Okay, so they are submitting their assignments. A lot of assignments are there already here. If you can see this stream, so maybe you can see this all the assignments they are submitting. They are taking pictures and submitting in the application. Okay, so yes, these are the assignments. Okay, let me show you something. This is the assignment that was based upon the Bohr theory. Okay, based upon the Bohr theory. So I just solved the Bohr theory in like SI unit, and I told you to solve the same thing in CS unit. So they are doing this so that they just get the idea how they should done it. Okay, they should have done it, because it's very important to like every time I am doing everything, it's not like fine, I will be doing half, you will be doing half, then it will be like you can easily understand, because without practice, without homework, without assignment, nothing happen. And another thing that generally in benzene batch I generally take, that is about like in video assignment. So in video assignment is what, like in the video whenever I am teaching you, suppose I have 10 examples, fine, and in that 10 examples I do have like 5 examples I have done, other 5 examples I will be telling the students to solve those and send them in the corresponding benzene batch assignment section. Okay, so then what happens, I am solving 5, they understand these questions how to solve those. Instantly after the live session, they just solve the left 5 one, right? Whenever they are solving the left 5 problems, they never like forget those questions. That's the positive like thing. But if I give you a PDF file where 50 assignments are there, okay, a lot of topics are there, and I am giving you 50 assignments and I am giving you at the end of the week, then what happens, you just ignore it, or you just get bored. Like that kind of things generally happens. You just get bored for that. You don't want to solve those assignments because you are likely to be feeling lazy. But if I give you 2 assignments in a day, 10 assignments in a day, 15 assignments in a day, you can do it easily. Okay, because I am teaching that topic, and based on that topic I am giving you assignments. So that generally helps. How much money we have to pay for the test? I forgot actually. Okay, I have to check that one. Okay, just okay, yes. Okay, as you can see, this is the course that you will be find over there. Okay, so that course is on like you can see this price is okay. The total price for this course is 949. Okay, so that's like one-time fees, and that would be available for JAM 2021. And within 2-3 days, I'll be uploading at least 5 to 6 tests at once, so that you can practice a lot more tests. Okay, So 5-10 questions then. Okay, so how much time we left? 4 minutes left. Okay, we only 4 minutes left. 4 minutes left. After 4 minutes we will be starting. After 4 minutes we will be starting that live session. Okay, after 4 minutes we will be starting solving those problems. So let me notify them, then I'm starting. Fine. Okay, so yes, yeah, yes, I just notified them. And yeah, I'll be starting within 2-3 minutes. 3 minutes left. Okay, after 3 minutes I'll be starting. Fine. So then you got to know like what kind of like questions you will be facing in IIT JAM examination from this chapter. Fine. And whenever I will teaching, I will teach you that. Then just do one thing: open your copy and pen. Okay, open your copy and pen and try to solve them on your copy, because it would be better if you solve this. You can definitely solve any kind of problem from this part, so that would be better if you solve this whenever I will be like showing you the questions and I will be solving you those questions. Okay, so that you have to do. Okay, so yes, I hope more or less students has already came. So if you are there, just do ask me, guys. English based students, if you are there, just do say hi, so that I got to know that you came. And it's like how much time? 43. 2 minutes left. 2 minutes left for our session. We are just 2 minutes left for our session. Okay, after 2 minutes I will be starting solving those questions like this topic. LBP, what is LBP BPH? This is the shortcut method that only Benjamin based students know till now. And then I will be solving the numericals. 4 different numericals, different kinds of numerical I will be solving, and I will be solving 3, and 4th one I will be telling you to solve those, and also at last I will be telling you how to solve the 4th numerical. Okay, that's all. That's all. Yes, Aditi, hello. So just wait for 1 more minute, Aditi, then I'm starting. Okay, it's 43. Okay, 43, let it be 45. 4:45, then I'm starting. Fine. So okay, so yes, the topic will be this. This will be the revision of this topic, LBP BPH. So Aditi, just tell me one thing. You are solving a lot of questions I can see, but are you watching those videos? Because you never join the live session, but yeah, I hope that you are like solving those questions and submitting those assignments, right? न्यूमेरिकल की प्रैक्टिस कहाँ से करे? मैं करवा रहा हूँ ना यहाँ से, तो यहाँ से कर लो. और यही बात कि न्यूमेरिकल कहाँ पे मिलेंगे, where would you find your numericals? That's not possible. Okay, a certain books are there, like A Ghoshal by like some other books, Amulendra Ghoshal. So that book that you would find, okay, you would find in your numerical section. But maybe there is no such books for numericals. Okay, you have physical chemistry books, like normal books, reference books, and from those books you can solve those questions. But there is no such books in the market except like Amulendra Ghoshal, Pahadi. Except those books, you can't read those books. Okay, just do try to buy those books like Amulendra Ghoshal, Pahadi for numericals, or just do read your reference books. That's all. Okay, so I hope it's 45. So I am starting. So how many of you are there? Just say hi once. Say hi once. How many of you are there? Say hi once. I am starting. And in between, whenever I will be teaching you, I won't take any other questions. Okay, I won't take any other questions whenever I will be teaching. So how many of you are there? Just say hi so that I can start. Okay. Yeah, got it. Any student from Benjamin batch? Because they should join. No, nothing else. Because students are not like Okay, yes, hello. Okay, Ashmin, yes, hello. Neha, Nena, hello. Okay, fine. So yeah, let's start. Fine, I'm starting. Yes, show me. Perfect. So I'm starting. So just this kind of question you will be facing from Bohr theory. So yeah. So hello everyone once again. So I'm starting this live session. Good afternoon to all of you once again. And in this video, we will be talking about this LBP-BPH. Okay, what is this? I'll be telling you this one. And along with that, I will be giving you some numericals based upon Bohr theory. Okay, actually I have already taught this Bohr theory in your Benjin batch, English or Hindi, whatever you say. And based upon that, I will be solving the corresponding numericals. So I hope you know already different formulas present in the Bohr theory and different things present in the corresponding Bohr theory or Bohr theory's limitation, summer fields, everything. Pradeep 100 plus. So this is our LBP and BPH. So it's very important. So in this, what are the spectral lines? So according to Bohr theory or according to spectroscopy, molecular spectroscopy, what happened whenever you are considering the molecular structure or the atomic structure, so one atom does have different kinds of spectral lines. You would get different kinds of spectral lines. So one spectral line could be Lyman series, Balmer series, Paschen series, Brackett series, Pfund series, Humphreys series. So these all kinds of series you will be getting. And you have to remember these all Lyman, Balmer, Paschen, Brackett, Pfund and Humphreys one by one. You have to remember in this order. If you are saying Lyman, Paschen, Balmer, Pfund, Brackett, Humphreys, no, it won't work. You have to remember this Lyman, Balmer, Paschen, Brackett, Pfund, Humphreys in this correct order. Okay, let me make myself small a little bit, then it would be better. Okay, fine, now I have, it's fine. So in this series, how would you remember this? That in this correct order, how would you remember? It's very simple. LBP, there is a shortcut method that calls like LBP BPH. LBP BPH. What do you mean by that? L means Lyman, B for Balmer, P for Paschen, B for Brackett, P for Pfund, H for Humphreys. LBP BPH. Just say twice LBP BPH, LBP BPH. That means Lyman, Balmer, Paschen, Brackett, Pfund, Humphreys. So you just need to remember this thing in this order. So why this order is important? It's important because in the case of Lyman series, what happens? Look at this picture. In case of Lyman series, this is your n equals to 1 orbit, that is also called k orbit. Orbit, I am talking about orbit, not orbital. This is Bohr theory. There is no concept on orbital. Only orbit concept is there. First one, K, L, M, N, O, P and dot dot dot. So first orbit K, second orbit L, third orbit M, fourth orbit N, O, P dot dot dot. So based upon this, you will be getting different kinds of series. So what about Lyman series? So Lyman is the first one. That means this Lyman you can do for n equals to 1. That means n equals to 1, first orbit. So when any transition happens from any other orbit to any other higher energy orbit to the k orbit, any other higher energy orbit to the k orbit, maybe the transition is happening from second orbit to first orbit. That means first orbit means n equals to 1. Third orbit to first orbit, as you can see, fourth first, fifth first, sixth first, whatever is happening. If transition is happening to this first orbit, you will be getting only Lyman series. Okay, you will be getting only Lyman series. If transition is happening transition is happening at n equals to 2, like this, second orbit, right? N equals to 2, L. It is happening from 3, 4, 5, 6, from where it is happening, it doesn't matter. It is happening, transition is happening at the second orbit. That's why it's Balmer series. Similarly, Paschen, third one, Brackett, fourth one, Pfund, fifth one, and Humphreys I haven't shown. The same thing generally occurs like this. So for Paschen, n equals to 3, for Brackett, n equals to 4, for Pfund, n equals to 5, for Humphreys, n equals to 6. And these n values are the destination of electrons. That means if electrons are coming to these orbitals, you will be getting corresponding to these orbits. Orbit number 1, 2, 3, 4, 5, 6. You will be getting corresponding series, spectral series. For 1, Lyman, second, Balmer, third, Paschen, fourth, Brackett, fifth, Pfund, sixth, Humphreys. That's the logic. LBP, BPH. You need to remember in this order. Otherwise, this 1, 2, 3, 4 things won't work. Not only that, here another part is very important. That is about alpha, beta, gamma lines. Not only alpha, beta, gamma, delta, and further dot dot dot. I don't need to know. These 4 will be enough. Okay. So as I told you, if transition is happening to n equals to 1 like this is your n equals to 1 first orbit, right? So if transition is happening to n equals to 1 from n equals to 2, that means 1 and 2, gap is 1, then for this transition you will be getting alpha line. Okay, if transition is happening from n equals to 3 to 1, that means 3 to 1, 3 minus 1 equals to 2, gap is 2, that means from here to here alpha, here to here beta, here to here gamma, here to here delta, here to here dot dot dot. Okay, so here transition is happening for in this like n equals to 1 line. So you already know n equals to 1 means Lyman series. So whenever you are getting this alpha, beta, gamma, delta transition, and transition is happening to n equals to 1 orbit, you would be saying that will be my alpha Lyman. Okay, if from here to here happening alpha Lyman, here to here happening beta Lyman, here to here happening gamma Lyman, here to here happening delta Lyman, here to here happening dot dot dot. More names are there, so those will be there. So this alpha, beta, gamma, delta is important. So this alpha, beta, gamma, delta is true for Lyman series. This alpha, beta, gamma, delta is true for Bohr series, Paschen, bracket, Fund, Humphreys. For every series, this alpha, beta, gamma, delta is valid. That means if I am taking this alpha line for like second orbit, that means transition is happening at the second orbit. So from third to second, gap is 1, alpha line, alpha Bohr, not Lyman. Now alpha what? You can see this alpha. So alpha Bohr. From here to there, beta Bohr, gamma Bohr, delta Bohr, dot dot dot. Got it? So now give me the confirmation that you understood the concept of alpha, beta, gamma, delta line. These alpha, beta, gamma, delta all are true for all these lines, all these individual series. So for Lyman present, for Bohr alpha, beta, gamma, delta present, for Paschen it's present, for this it's present, for this it's present, for this it's also present. So if it is clear, write C in the comment box. If it is clear, write C in the comment box. I need confirmation from everyone that you understood this. Okay, then I will be moving to the numerical problem. Okay, good, very good. Okay, actually I told you this thing in the last Bohr theory video. Fine, I told you this one already in the last Bohr theory video. So I hope you understood, because yeah, perfect. So I hope you understood all these things. Then I am moving to the corresponding like numericals. So this is our numerical number 1. So guys, calculate the radius of the first Bohr orbit. Look at this. Focus on this word. Okay. First Bohr orbit. Velocity and the energy of the electrons in helium plus in the ground state in both CGS and SI unit. So this is a very big question, but in IIT JAM they won't ask you like everything from this. They can ask this, they can ask this, they can ask also this. They don't ask like all the information, but through one problem I will be solving all those possible like things that I can do with this problem, and I will be solving different kinds of like problems. So even IIT JAM examination you can face questions like calculate this, calculate that, or calculate that. In CGS unit or in SI unit, they can ask anything. So if you can solve this question, you can easily like get all those things in IIT JAM examination. Fine. So how to do that? How to solve this question? How to solve this question? It's very important and very easy also as well as. So you know, let me solve this question in first CGS unit. Okay, I will be solving this question first in CGS unit, because unit conversion is very important over here. Okay. CGS. Okay, so let me solve this one first. Which one? This one. First Bohr orbit in CGS unit. I will be finding this, and then after finding this first Bohr orbit in the CGS unit, I will be solving the same in SI unit. Okay, so one by one we will be solving that. Okay, let's solve it. Question number 1 in CGS unit. Question number 1 in CGS unit. Okay, let me choose my color. Question number 1 in CGS unit. Okay, so do you know what is the formula of like radius in case of Bohr theory? In CGS unit, the formula is actually this: Rn equals to n square h square divided by 4 pi square m z square. Okay, and don't forget they asked to calculate the values in for helium plus system. So now consider the helium plus system. For helium, how many electrons are there? This is one electron system, because helium has 2 electrons, but as it is helium plus, it is one electron system, right? That means Bohr theory is applicable over here. Why? Because Bohr theory is only applicable for one electron system. Perfect. Got it? Then coming to the next one. Helium, in case of helium, Z value is equals to 2. Why? Because in case of helium, number of electron is 2, number of proton is 2. But in case of helium plus, number of electron is 1, but the number of proton is not changing. Number of proton is 2. So Z is the number of proton, that is 2. So these two things are generally variable, right? So now tell me, first Bohr orbit, they just wanted to get first Bohr orbit, that means n equals to 1. So you need to calculate R1 value. R1, that is equals to 1 square multiplied by, put the value of h. In CGS unit, what is the value of h? Do you know? If you don't know, just write down 6.625 or 6.626 into 10 to the power minus 27 arc multiplied by second and square of this. Okay, got it? Perfect. So now again, once again, 4 pi value is 3.14 square. Mass of electron, what is the mass of electron? You already know, 9.11 multiplied by 10 to the power minus 28 gram in case of CGS unit. Fine. Then Z value is equals to 2, and finally I will be putting the value of charge of electron, that is 4.8 into 10 to the power minus 10 ESU in CGS unit and square of this. I have put all the values. So once I put all the values, because why I am showing you all these values, because most of you I know are not care about, you don't care about this value. You forgot sometimes the unit, sometimes forgot the power of this. Okay, so that's why I am writing all these values. Then you just sometimes forget about become confused between CGS value and SI value. So be careful. Whatever I am writing, please note down everything, because it is very important. It is in CGS unit, this value is in, okay, let me show you. In CGS unit, this value is in ESU, electrostatic unit. Fine. So once you are doing this, and then in the next step, R1 will be what? R1, if you put all these values, so R1 will be, you will be getting values like this. Let me show you. If you do all the calculation, I am not doing the calculation, you do have your calculator. I am not doing the calculation, you just do the calculation. I am showing the calculation directly, but I will be showing you how these units are getting changed. Okay, all these units, I will be playing with the units, but this multiplication, division, or everything I am just writing into 1 word. You will be getting the value 0.265 into 10 to the power minus 8. Okay, this value you will be getting, and finally you will be getting like your unit. I am writing the unit only, arc second and square of this. Perfect. Here gram multiplied by ESU square. Okay, so now guys tell me, I am calculating radius. The unit of radius should be centimeter in case of CGS unit. That means from here I need to get centimeter. But how would I get that? Here I have my like ESU, here I have my ESU, here I have my like arc. How would I calculate that? So can you tell me guys, what is the relation between this ESU or arc, or like other conversion? Do you know what is arc? What is arc? What is arc? Can you tell me guys, what is arc? Can you tell me what is arc? If you want to convert arc into other terms, what will be the arc? Anybody? Anybody of any one of you? Can you convert arc into like centimeter, meter, gram, like that? Can you convert? Anybody? I am just waiting. I am giving you 30 seconds for that. I am giving you 30 seconds. Okay, joule. No, not joule. I am telling you, you are working with CGS unit, right? You are working with CGS unit. Now tell me, you just need to get centimeter, because you know the radius. You just in examination you just put centimeter, I know, but how we are getting this centimeter? Because you don't know how to play with units. You don't know how to play with units. That's the problem. Anybody? One arc, convert one arc to like convert it into gram, semi or second, like that. Convert it into these terms. Force, okay, very good. You have just achieved one step. Force into area, that is work. Yes, work. But arc is the energy. Arc is the like unit of energy, not work. Yeah, work is the form of energy, but yeah. Force. Yeah, you are right. Why you are deleting your comment? I have seen that one already. Okay, just tell me. Anybody? Okay, it's okay, no problem. Listen, so that you just need to notify them. Okay, so what I am doing, I am just taking this part from to the next slide so that I can show you how these units are getting converted. Okay, for that I just need to incorporate. I just got the second question. Okay, I can send it over here. Okay, now I'm just copying pasting it over here that I got already. Now arg means generally arg. Let me write over here. Arg means actually gram centimeter square second to the power minus 2. Okay, simple. Then ESU. What is the ESU? So can you convert ESU to other unit? Yes or no, tell me. Can you convert ESU to other unit? Guys, anybody? It's very tough, but yeah, you have to learn that. So whatever I am telling you, just write down over here. ESU means nothing but like whenever you are converting ESU from the system, this ESU will be gram to the power half, centimeter to the power 3/2 and second inverse. Remember this one. Okay, R equal to dyne semi equal to centimeter square centimeter d by using dipole moment. Okay, using dipole moment. This ESU means I am telling you convert ESU into CGS unit. So ESU means gram to the power half, centimeter to the power 3/2, s to the power minus 1. So you need to remember these things. Okay, ESU arg means what? Okay, if you know the unit of force, force means what? M L T to the power minus 2. Okay, this is what force. Into distance, if you do into distance, that is what becomes work, W. So work is the form of energy and arg is the unit of energy, right? Arg is the unit of energy, work is the form of energy, arg is the unit of energy. That means M, L, D, distance means L, M. Finally what you get? You get M, L, 2, T to the power minus 2. Mass, gram. Length, centimeter square. T, second minus 2. You got? So I got one correct answer from force into F into S. No. Anybody? Arg equal to dyne semi equal to centimeter USU per semi. Okay. Anybody? Any small and simple answer I just wanted to get you. So I hope you got it, how you can convert arg into gram semi like that. So already you know arg is what? Arg is the unit of energy, right? And you already know arg is the unit of energy. Arg is the unit of energy, right? Energy. Perfect. And energy, work is the form of energy. Work is the force into distance. Force have dimension M, L, T to the power minus 2. And distance has dimension L. Now multiply it M, L, 2, T to the power minus 2. That is the dimension of work. That means what is the form of energy and arg is the unit of energy. That means arg is the unit of arg's unit and work's unit. What will be the same? That's how I am getting it. It's very simple to remember. But yeah, if you can't remember this, remember that. It would be better if you understand this and then try to remember this one. Okay, that's how you can play with this unit. Okay, let me keep it here. It would be helpful for you. Now we got this. Now we just need to put the value. Okay, so R1 is equal to 0.265 multiplied by 10 to the power minus 8. Then I am putting arg means what? Gram centimeter square second minus 2, right? Then I think I am right and I will be doing this. Then here I am getting gram. ESU means what? Okay, gram half centimeter 3/2 second inverse, like that. This one. What about joule? Okay, joule is the SI unit of that. Okay, I am not talking about joule right now. I will be talking about joule also. Just wait for some time. Then I am putting the value this. Okay, and if I do this, should I get the unit of like okay, arg into second. Okay, arg into second. Fine. So now let me convert this value. Here I am also getting square. Perfect. So then let's try how to get that. Okay, is that clear? If it is clear, write C. Till now if it is clear, write C. I just put the value. I have just put the value. Okay, yeah, got it. So then do one thing again. R1 equals to 0.265 multiplied by 10 to the power minus 8. Then gram square centimeter to the power 4. Okay, it would be very tough. Then like s to the power minus 4 s square. Then gram. So it will be like gram to the power gram centimeter 3 second minus 2. Perfect. This one, they will get cut. Gram square cut. Centimeter cube centimeter. Only 1 centimeter will be left. R1 equals to 0.265 into 10 to the power minus 8 centimeter. This is your answer. And if you don't know 10 to the power minus 8 centimeter is equals to 1 Armstrong. If you don't know, remember. Okay, so you can write the answer. R1 equals to 0.265 Armstrong. And if you don't know still, 1 Armstrong is equal to 100 picometer. Remember this, write this one also. 1 Armstrong is to 100 picometer. That means 26.5 pm. Your answer also can be 26.5 picometer. So first Bohr orbit for helium is this. Did you get this? Did you get this, guys? Please tell me. Because if you don't learn how to convert this, you may have problems. These things are boring, I know. But most of the students don't understand how to convert these things. You will just put centimeter, but it will not work always. Maybe you need to convert the unit into other parts. So you just need to remember by practicing all these things. Okay, so I just this unit into this and ESU in from like I just remembered this one. Okay, perfect, very good. I hope it's clear. So I have converted this centimeter to Armstrong to picometer, and I have given you all the important relations. So note down this relation and how. Okay, note down this relation. Note down this relation. These 4 relations you have to note down right now. If you don't note down, maybe you know this, or otherwise you are not caring about this. Maybe. Okay. So now I hope it's done. Everybody of you just copied it. Everything you have done in right away, because you know already why I am doing this. Doing the calculation, it's not tough. You can do it easily using your calculator. But doing this thing is very, very tough. That's why I am showing you. Fine. So I have calculated my first Bohr orbit for helium plus. That means only variation will be z equals to 2, n equals to 1. And I have calculated this value. Now I want to do it in SI unit. I have done in CGS unit. Now I want to do in SI unit. Okay, so again I need one page, so I need to import that one. SI unit. So do you know what is the value of like first Bohr equation of Bohr orbit in SI unit? It's very simple. N square h square epsilon naught divided by pi m e square z. Okay, this is the equation. So now can you tell me guys, can you do this? Can you do this? Simple. Again n equals to 1, z equals to 2. Okay, these are the two things that you have to take care of. Then just do the same thing. R1 will be equals to 1 square multiplied by other terms like you need to remember, now we need to put the values in SI unit, okay, not CGS unit. So I am putting all the values in SI unit. Fine. H means 6.626 into 10 to the power minus 34. Initially it was what? Arc second. Now it will be joule second. Okay, now I am giving you one relation regarding this. 1 joule is equals to 10 to the power 7 arc. Even note down this relation. I have given you fifth relation. This is my fifth relation. So note down all the relations, whatever I am giving you. It will be present in one place if you note down everything. I will be solving those numericals. Along with that, I will be giving you those informations. Fine. Joule second. Perfect. Next. Epsilon 0 in SI unit. What is the value? Its value is 8.85 multiplied by 10 to the power minus 12 Coulomb square Newton inverse meter to the power minus 2. This. Okay. Okay, it will be square. I am sorry, it will be square. Don't forget to put square over here. Okay. This one. Finally, pi value 3.14. M value what in SI unit? Remember, mass of electron in SI unit 9.11 into 10 to the power minus 31 kg. In case of CGS unit, it's minus 28 gram. It's SI unit kg. In charge of electron in Coulomb, what it will be? It will be like 1.602 into 10 to the power minus 19 Coulomb. Done. Square. Finally, Z value is 2. I got this everything. So if you calculate this, you will be getting the result. If you calculate this, you will be getting the result. Okay, if you calculate this, you will be getting the result. So I think I will not be solving this. Okay, so you can easily solve this problem. I will be getting 0.265 multiplied by 10 to the power minus 10. Now I have to play with units. Let's do it. Joule second square into Coulomb square Newton inverse meters minus 2 kg Coulomb square. That is the total. These are the total units. Fine. So from here you already know you are doing this calculation in SI unit. That means your radius will be in meter. You know this already. Meter, because radius should have value of length, should have a unit of length. So how would you get that? How would you get these units? So you just need to convert. Okay, you can see, just cut those parts which are not necessary. Coulomb square. Fine, it's not necessary. Now you have to convert this value, this joule value and this Newton value, or just convert this value of joule. Okay, let's do it so that we get the value of like meter. So initially what I got, arg means gram centimeter square second to the power minus 2. So what will be the joule means? Joule means what? Kg meter square centimeter minus 2. Kg meter square centimeter minus 2. Not centimeter, it's second minus 2. Same thing, I just changed the units from here to kg. Here I have made kg, meter, second is second in case of SI unit. Okay, it's simple. So now let me put those values. 0.265 multiplied by 10 to the power minus 10. Then kg square, joule square is there, meter to the power plus 4, second to the power minus 4, Newton to the power minus 1, meter to the power minus 2, and in the below side it's kg. Okay, now it's not done. I have to put the value of Newton. So Newton is the force of Newton is the unit of force, right? You know this. Newton is the unit of force, Newton. So Newton means what? You know, force means m l t to the power minus 2, mass kg, l length meter, t second minus 2. Newton will be this. Let me put the Newton over here, and it's inverse. That means it will be kg inverse. Okay, let me put this minus 2 first, then I am putting the Newton. It will be like kg inverse, m inverse, second 2. This. You just try to see from here. So this and this two will cut. Then meter 3, 1, 2, 3. I will be getting only 1 meter. And finally, okay, I just missed one thing. Try to remember, guys. What I missed? Can you tell me? I just missed this second square. I put this second to the power minus 4 by joule square, this, but I missed this second square. Now cut this. Second square, second to the power minus 4. What I am getting? I am getting only this meter. That means here meter. Yes, good, Shivras. Perfect. That's all. So now again give me the confirmation that did you understand? If it is clear, write C. Just write C. So I need everybody to clear. If you want me to repeat again, just tell me. I will be repeating everything. How I am getting meter like meter square? How? No, I am not getting that. Why? Meter inverse, meter square, inverse square, m to the power minus 3, m to the power 4, minus 3, 4, only m. That's what I am getting. So my unit will be this to 0.265 multiplied by 10 to the power minus 10 meter. That means that includes 0.265 Armstrong. That means 1 meter, sorry, again I have to import pages. Let me take a lot of pages. That means what happens? 1 Armstrong is equals to 10 to the power minus 10 meter. Initially I told you 1 Armstrong is equals to 10 to the power minus 8 centimeter. Very good, yes. That's all. That's the method. You can do this. Okay. And again same you can do this. 1 Armstrong is equals to 100 picometer. That means final answer if you want to write, that means R1 in SI unit will be again 26.5 picometer PM. But as I told you to calculate the value in SI unit, that means your value is this meter. Okay, perfect, very good. That's all. That's the product, that's the answer. So this is how you can do this. This is how you can do this. So we have calculated this one only. First Bohr orbit. Next we have to calculate the velocity. So yes, you can calculate the velocity in a similar way. You can calculate the velocity in a similar way. How you can calculate that? It's very simple. Let me write the formulas first. Now I want to calculate the second thing, right? I want to calculate the second thing, velocity. velocity. Second, velocity in CGS unit. Vn, formula is what in CGS unit? Vn equals to nh divided by 2 pi m rn. So I already calculated the values of radius, so why would I put like r value again? So this is true for n equals to 1 and helium atom, that means z equals to 2. So let me put v1 is equals to 1 into h 2 pi mass of electron multiplied by r1. So I already know the value of r1 in terms of SI CGS unit and SI unit both. I will just put the value of r1. Why would I calculate again? No. v1 equals to 1 multiplied by h CGS unit, 6.626 multiplied by 10 to the power minus 27 arc second. Then 2 multiplied by 3.14 multiplied by 9.11 into 10 to the power minus 28 gram. And finally, what value I would put? 0.265 multiplied by 10 to the power minus 8 centimeter. So if you can't see this, just see from here. I'm just moving, just see from here. Also I am stretching my body at the same time. Have you put this value? I'm sorry for that. Yeah, have you got this? Yes, fine. Okay, you know this. I just put the value in CGS unit. Okay, so if you calculate the values, what value you will be getting? V1 will be equals to, now try to understand, here you are getting arc second, here you are getting these things. So I am just putting you the value, like the value that I am getting 4.36 into 10 to the power 8. And what will be the unit? Again play with unit. Arc second, and in the below gram semi. So what I will do, I will just change the arc into different unit. I know what do you mean by this arc? Let me show you. Arc means what? Gram centimeter square second minus 2. Gram centimeter square second minus 2, and this second again. This cut. Centimeter square I am cutting. Gram second this. So it will become second inverse. So the velocity is what? V1 equals to 4.36 into 10 to the power minus 8. 10 to the power minus 8 gram. Okay, so I'm sorry, centimeter per second or centimeter second inverse. V1 equals to this. Now guys, tell me, is that clear how I am doing this calculation? Is that clear? If you learn this, it's quite easy. It's very easy. Is that clear? If it is clear, write C in the comment box. Write C in the comment box. Then I am going to the next problem. It's time to give you some homework. Okay, it's time to give you some assignment on that. If you don't understand, please do ask me. So I hope you have copied this one. Okay, good. Assign homework for benzene batch students. In SI, calculate the V1. Okay, and submit it to the benzene batch A/E. Okay, this is your homework. Submit it over there. Perfect. Got it. Next. So I am not going to do the same thing for SI unit. No, I am not going to do that. I am going to the next part. What they are asking to calculate. Third, what I need to calculate? I need to calculate this. Energy of the electrons. Energy of the electrons. Okay, in CGS and SI unit. So what I am doing? Let's calculate the energy. Number 3. Okay, let me do this in the next slide. Energy. En. What is the equation? Energy of energy in CGS unit? CGS. Okay, what is the equation? In case of CGS unit, the equation is En is equals to what? Okay, did you remember? There is one negative sign. I forgot the equation. Okay. Can you remember this equation? I just forgot the equation. But in examination, for the examination part, you just need to remember that. I think it was like minus, what was that? 2 pi. Okay, maybe it is 2 pi square m z square e to the power 4, and finally here n square h square. Okay, 4 pi epsilon naught 0 will not be there. Yes, this is the equation. This is the equation in CGS unit. Okay, so what I need to do, same thing, n equals to 1, and for helium z equals to 2. Perfect. Let me put the value. E1 will be equals to, okay, negative sign will be there, 3.14 square mass of electron 9.11 into 10 to the power minus 28 gram. Then z square 2 square, E value 4.8 into 10 to the power minus 10 ESU. Finally n value is 1 square, H value 6.626 into 10 to the power minus 28, not 28, 27 arc second square. That's the thing. I have done the same thing for this one again. So final equation, final value, what you will be getting? E1 will be equals to minus 8.72 into 10 to the power minus 11. You will be getting this value. And finally, from this part, all other unit part, you will be getting unit. What will be my unit? You know, you are calculating energy in CGS unit. Definitely your value will be arc. In energy of unit will be arc. So let's see how I am getting arc. Gram, ESU, and from here only arc second. So you already know what do you mean by this arc and what do you mean by this ESU. So let me show you again. Arc means what? Okay. Arc means gram centimeter square second minus 2. Gram half centimeter 3/2 second minus 1. Let me come back. Gram centimeter square second minus 2 and second. This is my below side. This is the system, the thing that is present in the first bracket, arc and second multiplication. What is this? Gram to the power 1/2, centimeter to the power 3/2 and second inverse. This is the value for ESU. Perfect. And yes, it's perfect. Okay, here it will be 4. ESU 4, so I have to put 4 over here. I just ignored that 4, and finally it will be square and it will be also be square. So let me write this thing again. Gram centimeter square second minus 2 square. This is arc and second square. Why? This arc second was like arc square second square, arc square second square. I hope you got that. Now I'm just doing the calculation for this. Okay, I'm just doing the calculation for this. Gram, and from here I will be getting gram square, then centimeter 6 second minus 4, gram square. Okay, I think am I doing something wrong? Am I doing something wrong? Yes. Okay, let's try that. Gram centimeter 4 second minus 4 and second square. Cut centimeter square, cut. So what I am getting? Guys, look at this. E1 equals to minus 8.72 multiplied by 10 to the power minus 11 gram centimeter square second to the power minus 2. What I put? Gram centimeter square second to the power minus 2 in the place of arc. That means this means arc. My unit is, energy is minus 8.72 into 10 to the power minus 11 arc. Simple. This is your answer. In CGS unit, you have got your energy of this arc, energy value in arc. Okay, that's all. Is that clear? I just played with the units. I just converted the units. So what you need to remember? you need to remember these two values only, these two relations only. If you remember, it's quite easier. For CGS unit, that I have shown already. This is your values. If it is clear, write C. If you have confusion, write confusion, a bigger term. Then I am moving to the next question. So in CGS unit I have done that. You think you can do it easily, but whenever you will be trying to do that, you would face problem. That's what I was facing. But I solved this one. But you will be facing the same problem whenever you will be trying to do this. That's why I am telling you, in unit conversion is very important for physical chemistry, especially in JAM examination, because they will try to play with your minds, okay, play with your memory. IIT JAM administration generally gives you these kinds of things. So this is in CGS unit. Okay, again I need slides. What will happen in case of SI unit? So I am just writing the equation for SI unit, and left thing you have to do it. En equals to minus m z square e to the power 4 divided by 8 epsilon 0 square n square h square. So I hope you can put all the values. Okay. So you just need to put n equals to 1, z equals to 2, epsilon 0 is value what? I told you already, epsilon 0 has value 8.85 multiplied by 10 to the power minus 12 in SI unit. Definitely in case of SI unit this term appears. Coulomb square, Newton inverse and meter minus 2. This is the unit and this is the value of epsilon naught. So now I hope you can easily calculate the value of this. Okay. So this is your again homework. I am not going to solve this. And energy unit will be in joule, but don't write joule directly, please. Write joule after unit conversion, please. Okay. So this is your homework. Solve it and submit it to the benzene batch A/E. Perfect. I have given you the hints how to do that, but you have to solve this. I hope you have noted down this. Okay, so now moving to the next part. So I hope this question has been solved. Okay, which question? This question. I have calculated these fast Bohr radius, velocity and energy of helium plus. If I give you for lithium 2 plus, you can also do that. Beryllium 3 plus, you can also do that. Only Z value will change. Z value 2, 3 or 4, and that can be anything. First question is done. Now moving to the next question, second question. This one. If you think this question is easy, yeah, it's easy. But if you, because I taught you this concept of ionization potential, how to calculate that. How to calculate that, I taught you this one. Ionization potential, IP. But I am asking you to get the third ionization potential for lithium atom. For lithium atom, calculate the third ionization potential. Can you calculate this? Or guys, one question. Can you understand what about the why I am asking you to calculate the third ionization potential? Because this is the application of Bohr theory. So why I am asking especially for the third ionization potential of lithium? Why not first or second ionization potential? So what is first, second, third ionization potential? Let me show you. Lithium in its stable ground gaseous state, minus 1 electron, or like it is becoming Li plus. This is called first I or IE1. Second, in case of lithium plus gas ground state, IE2, like lithium 2 plus. And this is my Li2 plus, GIE3, lithium 3 plus. Very good. Did you get it? Any one of you got this answer? So what will be third ionization potential? Absolutely, Shadi, you are perfect. You are good. Why is that? The logic behind this is, if I am talking about first ionization potential, you know hydrogen, helium, lithium, it's a 3 electron system. But Bohr theory cannot be applied for 3 electron system. After first ionization potential, I am getting 2 electron system. So it is 2 electron system. So it is what? Li2 plus is 1 electron system. So Li2 plus is one electron system. So third ionization potential means first one, second one. So from one electron system, you are losing another electron like this. So Bohr theory is applicable only for one electron system. Only for one electron system. That can be either hydrogen atom, that can be other hydrogen like atom. Those have only one electron. Perfect. Bohr theory can only be applied for one electron system. Perfect. That's all. Okay. So because of that, I need to calculate first third ionization potential for this. If you are talking about first, it's not possible through Bohr theory. Second, it's not possible for Bohr theory. Only if you want to release last electron, that means lithium 2 plus is one electron system. And in this one electron system, if you want to ionize this one electron, you can apply Bohr theory, that how much energy you need to incorporate to do this job. That you need to calculate. What is the formula? Very simple formula is that. What is that? Can you tell me? Can you write in the comment box what is that formula to get the third ionization potential? Can anybody tell me that? Anybody tell me that? Anybody? Okay, it's very simple, yes. But I am starting from the beginning. Okay, I am starting from the beginning. Okay, I will be giving you the simple formula, but let me tell you what is ionization energy. So listen, after releasing two electrons, lithium 2 plus does have only one electron. So you have to release this one electron, and how much energy is required for releasing this one electron? That is our third ionization energy for this. Okay, so ionization energy means this has one electron, one electron is there, still there. So from here, that means it is from the nucleus, the distance is r, and you just need to release this electron, and you just need to you just need to take this electron to infinity. You just need to take this electron from r distance to infinity with respect to nucleus. So now from nucleus the distance is infinity, from nucleus this distance is r. So if you want to take this electron from infinite r here to there, how much energy you need to incorporate? That is important. So which formula you would use? And remember, you are just releasing this electron from here to there. This is higher energy orbit, this is lower energy orbit. So what is your formula generally? You already know the formula is like ionization potential. Your formula is this. In case of SI unit, what is the formula? Z e to the power 4 m 8 epsilon naught square h square. Okay, and 1 divided by n1 square minus n. Okay, I am sorry. Here it will be n r square, and here n infinite square. This is our formula that I am getting from here. Okay. So what happens here? What happens here in this case, why I am not using like nu bar equation? Shady, you can think why I am not using like nu bar equation. If we calculate nu bar, I will be getting the value in centimeter inverse. Then I have to convert this centimeter inverse value to kilojoule or joule or r, anything. So I am directly taking normal value, like what? Energy equation. So what I have done? Initially, let me show you what I have done. Initially, what is ionization potential? The energy difference between this and this. So higher energy is this, that means E infinity minus E like R. Okay, this is the difference. So this is the energy difference between this energy and this energy, and this energy difference is called like the ionization energy. Simply, this energy difference is my ionization energy. That's what I need to calculate. So from here to there, how much energy I need to incorporate, or how much energy difference in between this infinity state and this state, that I need to calculate. So just put the value of infinity, put the value of R. How? Using this equation. Using this equation. Okay, using just only this equation. That value you will be getting in joule. That value you will be getting in joule. So if you are, which will be the variation? This will be constant. This will be constant for both these cases. Constant, constant. This is also constant. So only variation is this. And you are getting only negative charge here. Because of that, whenever you are doing this negative, this term that means NR is coming first. This is going later, because I just rubbed this negative charge and multiplied the negative charge over here. And I just took the common part outside from the first bracket. That's all. Okay. I hope you can visualize that. Otherwise, you can just convert in normal way. This is the energy difference. So I just need to send these electrons from here to infinity. So how much energy difference is creating? That energy I need to incorporate from outside, and that would be your value. Okay, that would be your value. So n infinity, that means number of, here value is infinity, means the infinite number of orbit, the infinite number of orbit, that means this value is infinity value. In the next line you will be writing infinity square. So 1 divided by infinity, what is that? 0. Rub it. 0. Only this part will be there. From where it is going? What is the NR value? So as it is one electron system, so one electron generally presents in first orbit, right? It will not present in last orbit. No, one electron is there, so it will be present in k orbit or first orbit. NR value will be 1 and 1 square. So 1 divided by 1, that becomes, that means nothing. That means nothing. Okay, that means nothing. Hello, that means nothing. So once you put all this value, what will be the Z value over here? You are playing with lithium 2 plus. So number of electron is 1, but number of proton, that means Z is equals to 3 in case of lithium. Okay, so 3 multiplied by this value, 4 multiplied by mass, then 8 value put like epsilon 0 square, H value square. So put all these values. This is your homework I am giving you. This is your homework. Benzene batch, this is your homework. Put all these values. And finally, what value you will be getting? You will be getting this ionization potential value into which unit? Into which unit? Into joule unit. Okay. So what will be the final value? Your value will be like 21.8 into 10 to the power minus 19 into, okay, it will be Z square. I am sorry, it will be Z square, 3 square into 3 square joule. That's all. That's all. This is the lengthier method. There is a shortcut method. Okay? There is a shortcut method to do that. Do you know what one? Which one? The shortcut method is ionization potential is equals to, you need to incorporate energy. Okay, so you don't need to have put negative charge, negative sign. Negative sign means system is doing work. No, you are doing work, you are adding energy to the system, so negative charge will not be there. The smallest simple formula is 13.6 plus 13.6 Z square divided by N square. Electron volt, this is the simple formula to get ionization potential. Ionization potential, okay. Simple value for ionization potential. So now tell me guys one thing. Z value is what? 3. N means from where you are sending electron. You are sending electron to infinity. From where you are sending electron to infinity? From where? From n equals to 1, right? That's why you put 1 over here. Remember, this value will be 1. So now just do it. IP will be equals to 13.6 multiplied by 3 square, and this is 1, that means 1 electron volt. So convert this electron volt into joule. How do you get that? This will be like, okay, if you convert this value into joule, you will be getting, let me write the value. you will be getting like 21.8 into 10 to the power minus 19 into 9 joule. Okay, that means 1 electron volt equals to 1.6 into 10 to the power minus 19 joule. This is the important relation that you need to remember over here. That's all. So your ionization potential value will be joule unit in this and electron volt unit in this. Just do the multiplication with 9 and this. Okay, you will be getting that. It's quite simple. But if you want to, okay, that's all. Fine. Is that clear? How would you calculate that? That simple thing. Is that clear, guys? Is that clear? Yes or no? It's normal thing. It's normal. Just normal calculation. This is the shortcut method. To this equation, from where you will be sending electron, that's N. Which atom or what is the Z value number of proton in the corresponding system? Put the value of Z. It's tough to understand, but yeah, it's important. That I already told you in my ionization potential concept. What is that concept? That's all. Okay, otherwise you can directly use this concept or whatever concept I told you using the Bohr equation, get the value in centimeter inverse, then convert it into joule or kilojoule, like that, whatever you want. You can do that as well. Now coming to the third question. This will be the last question. The wavelength of the first member of H alpha of Bohr series of hydrogen atom is this. Wavelength is given already. Calculate the wavelength of the second member. Calculate the wavelength for the second member. That means you have to, this wavelength is given, lambda for alpha Bohr is given as 6563 multiplied by 10 to the power minus 10 meter. In SI it is given. You have to calculate lambda for beta Bohr. That you need to calculate. From here. How do you calculate that? So Bohr means Lyman Bohr, LBP Bohr, n equals to 2. Okay. So nucleus n1, n2, n3, n4. So n equals to 2 is this. This is alpha line, this is beta line. Okay. So n equals to 1, 2, 3, 4. That means for alpha line 3 to 2, beta line 4 to 2. This will be the alpha and beta Bohr line, right? So let me write the corresponding equation for this two transition. Nu bar alpha line equals to R, and this is 2 for which one? Hydrogen atom. Z equals to 1 for hydrogen atom. So I am ignoring the Z, okay? Z equals to 1, so I am ignoring Z. 1 by lower energy, that means 2 square minus 1 by 3 square. Alpha. Nu bar beta R into 1 by 2 square minus 1 by 4 square. These two values, and unit will be, this value will be in meter inverse, this value will be in meter inverse. Because I am talking because it is given in meter, so I will be doing this into like meter inverse. Okay, because you know Nu bar has a unit. Nu bar has unit like this. Nu bar means unit will be meter inverse or centimeter inverse. CGS centimeter inverse, meter in SI inverse, SI unit. Meter inverse in SI unit. That I told you in my benzene batch conceptual video. Okay. So these two unit you have already got. So what I am doing, just doing this calculation. So from this what I will be getting? For alpha 5 by 36 are meter inverse. This I will be getting after this like negative subtraction, and from this I will be getting like 3 by 16 are meter inverse. So Nu bar alpha means what? Okay, let me take this page again. Nu bar alpha, Nu bar beta, 5 by 36 are meter inverse, and then 3 by 16 are meter inverse. Just do the right division. Nu bar alpha divided by nu bar beta. 5 by 36 R and 3 by 16 R. Perfect. That's all. That what I will be getting? I will be getting, if I do the calculation, R will get cut. So 5 by 36 multiplied by 16 divided by 3. So 4, 18. 20 by 36. Okay. No. 4, 9. 20 by 27. Nu bar alpha divided by nu bar beta is equals to 20 by 27. Okay. So I can write nu bar beta. I need to calculate nu bar beta, right? Nu bar beta equals to 27 by 20 into nu bar alpha. Okay. And remember guys, nu bar alpha is given. Which one? This one. 6563 10 to the minus 10 meter. 27 by 20 into 6563 into 10 to the power minus 10 meter. So now I have to do the calculation to get this. Nu bar b equals to, nu bar beta equals to what? Just do the calculation. What value I will be getting? So I have written already there. Where is it? Okay. So I will be getting this value. For nu bar beta I will be getting this value. Fine. Okay, I am sorry, just one second, I just did something mistake. Nu bar is not given, lambda is given, lambda alpha, nu bar is not given. So here nu bar, what is it? Nu bar alpha, right? So you already know nu bar alpha means what? 1 by lambda alpha. Now put the value of lambda over here. 6563 into 10 to the power minus 10 meter inverse. Okay. Right. Now I have to calculate lambda, what it is given here, like 1 by lambda beta will be equals to this. 27 divided by 20 into 1 by 6563 into 10 to the power minus 10, and I am writing meter above side, that means it will become meter inverse. So 1 by lambda will be something meter inverse. So lambda will be something meter. So what will be lambda value? So if you calculate the lambda value, I am calculating over here. Okay, I am not going to the next page. Lambda value will be, if you do the calculation, it will be 4861 into 10 to the power minus 10 meter. This is your answer. Yeah, got it. This is your answer. Okay. So tell me, is that clear or not? Tell me. Is that clear or not? How I have just solved this question? So they just gave you this information for H alpha line. You just need to calculate for H beta line. Is that clear? How did I solve that? Is that clear? Okay, just do it. Solve it from here. It's just a normal problem. If you understand, it's fine. If you don't understand, please do watch the video again. This will help you a lot. If you don't understand that, do practice again. Take time. Take your time. Maybe you are not too fast like your friends. Okay, but take your time and solve this. If it is clear, write C in the comment box. Write C in the comment box. Write C. Then I am giving you a homework. I got 2 clear and other clearance are where? This is your homework. Solve it and send it to the benzene batch A/E in the assignment section. Solve this assignment and send it over there. Okay. So write down the problem, or you can just write down after this video will be uploaded in the live session. Okay, it will be uploaded in your corresponding benzene batch within 15 minutes after this live session. Okay, so just stay tuned over there. That's all. So write down the assignment. Write down the assignment. Submit it in the benzene batch, because I have taught you how to get this alpha beta line. So remember, here you are calculating for helium plus. That means Z will be equals to 2. Or if you have any specific problem, question, you can ask me right now. Okay, you took screenshot. Okay, smart job. Okay, great job. You took screenshot. Fine. So this is your homework, and you will be solving and sending it over here. Okay, this is very important thing. Okay, perfect. So guys, okay, that's all about this video. Okay, that's all about this video. And in the next video in benzene batch, what I will be doing, because benzene batch students are there, so I will be talking about Sommerfeld model. And I will be telling you, in case of Bohr theory, I told you Bohr theory has a demerit. That means Bohr theory cannot explain the fine spectrum. That means it can explain only, you should get only one spectrum, but in reality we get a lot of spectrum. In reality we get a lot of spectrum. So Bohr theory cannot explain the fine spectrum, no. But how Sommerfeld model can explain the fine spectrum, that we will discuss. And whenever we will be discussing this, like fine spectrum concept, then at that time how the concept of N, L, M, these three quantum number, that is L is actually ML, these three quantum number, how the concept of these three quantum number is coming, I will be explaining you in great detail. That will be your next topic, Sommerfeld atomic model. That will be maximum 1 hour live session that I will take, I think, tomorrow morning. Okay, but tonight I will be taking something else. Okay, so bye bye, meet you in the next video on Sommerfeld model, atomic model. Fine. So guys, if you have any problem regarding to this live session, you can ask me right now, or if you have any other specific question, you can ask me right now. Any question, any question. You are in the benzene batch, you are not in the benzene batch, whatever question you do have, you can ask me. That's all. So next video will be this. Any question? Or if you, okay, bye, goodbye, Shadi. Any question? Otherwise I am just leaving. No question. Fine. So bye bye guys, meet you in the next video soon.